Today we turn to a discussion of paired sample analysis, a particular kind of t-test that's often very useful to us in communication studies. Again, we should think of the paired t-test as a way to test our hypothesis, to examine if there are indeed differences. We assume, of course, that there are not, the null hypothesis, and we must demonstrate to ourselves if such differences exist with the alternative hypothesis. Therefore, this kind of analysis is a way to ensure against type 1 and type 2 errors. Type 1, the mistaken rejection of the null hypothesis. In this case, as we'll see, that there were not truly significant differences between two sets of scores. Or blindness, in which case there really were differences between the two sets of scores, and we did not see them. A paired sample t-test is a test procedure that compares the means of two variables for a single group. It computes the differences between the values of two variables for each case and tests whether the average differs from 0. In this particular case, we'll imagine that a graduate faculty has created a set of variables: writing and editing, document design, rhetoric, problem solving, collaboration, interpersonal communication, specialized expertise in technology for graduate students, and that achievement of these independent variables will produce a competent graduate student. In this particular data set, we'll be looking at two of these variables: writing and editing from a particular set of scores taken during a spring semester, here, and document design, a particular set of scores taken also during that semester. And what we'll want to examine is, are the scores for writing and editing different than those of document design? And if so, are those scores significantly different? In SPSS, we'll go to Analyze, we'll go to Compare Means, and we'll select the paired sample t-test. We'll select writing and editing and document design as our two variables of interest and put them in as paired variables. Under our options, we'll note that the software has preset the 95% confidence interval, the standard interval that allows us to see if we can indeed reject the null hypothesis and accept demonstration of an alternative hypothesis. If we hit OK, we'll see that SPSS has demonstrated that there are certainly differences in the scores that students received in writing and editing, a mean of 7.07, and document design, higher score at 8.29. The t-test will allow us to see if indeed those scores are or are not significant. We'll focus here on the degrees of freedom and the t-statistic. Our degrees of freedom are 0.66. Moving to our table of t-statistics at the 0.5 confidence interval, we'll notice that for such degrees of freedom, 60, the t-statistic would have to at least be 2.0. If we return to our analysis, we find indeed that the t-statistic is 4.144, meeting and exceeding the established t-statistic. The reason that it's negative, by the way, is because the former score is smaller, as we saw before, than the later score in this case. We therefore can assume that we have indeed reached, as the software tells us, a significant difference. And our analysis can suggest this. Therefore, an investigation of the independent variables of writing and editing and document design, two variables, a significant difference was indeed identified, and that the scores on the variable of document design were not only higher, but they differed significantly from the scores received in writing and editing. A paired sample t-test therefore allows us to compare the means of two variables for a single group.